Okay, so where we left off last time was this was our main function, and we had 3 member functions. Did I do the constructor last time? I think I did. Yeah. Yeah, I guess I would have to. Insert. Actually, well, never mind. Okay, so let's continue on, and let's add a find function to this. Okay, and I will tell you what the find function is supposed to do by writing some code that uses it in the main function. Okay, how's that? Does that make sense? So here's what's going through my mind as I'm typing this. The way that I've set up my find function here actually violates one of the style conventions. Anybody want to tell me what that is? Go ahead.
Found boolean is basically a return value for your passing boolean.
So right, so it's a pass by reference.
Okay.
Well, that's related to it, but there's nothing wrong with having a value that's getting returned through a pass by reference parameter. The style convention I have says that a value returning function should never have a pass by reference parameter. So anyway, I'm just throwing that out there, and I'm just going to go with this for now, and I'm going to think about it more later. Okay. Okay, so let's go ahead and declare our find function. Any other questions before I move forward? Okay. Any questions on that? There's my prototype. So, int all right. What's this going to look like? Any suggestions? Maybe the best place to start would be sort of conceptually, right? So the best place to start would be don't even give me any code. Just think about the picture of a linked list and tell me what you're going to have to do. Okay, so you're going to have to iterate through the list. So maybe to fill that out in a little more detail, how are you going to iterate through the list? A loop, okay. Anything? Any other details we can fill in? Go ahead. Okay, do you see it moving? Right, so moving a temporary pointer through the loop, excellent, okay. We're getting here step by step. So all that works fine now. I think the only thing we're missing is how we start, right? So if I were to ask you this, when I ask a question like that, was that a hand?
Yeah, I was going to suggest that maybe look a lot like the print function.
Okay.
And once you agree that you found the value, then you exit out the print.
Right. So it's going to be a lot like the print function, because the print function also iterates through the loop, right? The difference being that once you find the value you're looking for, you just exit the loop and return the value. Okay. So I guess when I ask the question sort of conceptually, what's this going to look like? Really, what I'm asking for is an algorithm, right? And so the algorithm for this would be something like, I'm going to start by having a temp pointer point to the first item in the list, and then I'm going to have a loop that moves that temp pointer down the list until I find what I'm looking for. Okay? So, and now that was an algorithm. I said that whole thing without using any sort of, like you would have no idea which programming language I'm talking about, right? Or even I might not be talking about programming at all. It could be I'm talking about a picture of a list on the whiteboard, right? So that's kind of what I'm looking for when I say algorithm, and really that's what you should have in your brain before you start writing any code, right? You shouldn't be writing any code if you don't have that algorithm at least in your head, if not written down someplace. So. Here's find. So I need to start by, I need a temp pointer pointing at list, right? Int star temp pointer gets list. Why is that underlined? Yeah. Thank you. Much better. Okay. And then I'm going to have a loop. It's looping down until, when does it stop? Actually, I'm going to call this cur pointer. And so while cur pointer, what? Help me out here. Arrow data not equal to target, right? While cur pointer arrow data is not equal to target, what are we going to do? Move the cur pointer down, right? So someone tell me that in code. Cur pointer gets that, right? Well, that expression represents where we want cur pointer to point now. So I just need to say cur pointer gets. Okay, so far? So what's true when we exit this while loop? By the way, that's an excellent question to ask yourself most of the time when you write a while loop, right? After I'm done with this while loop, what do I know is true? I can make an assertion. Right. That make sense? Because that's the opposite of the while loop condition. Okay? So that's just a little reasoning about programming that should be going on in your brain all the time when you're writing code. Okay, so now that I know that career pointer arrow data equals target, what do I want to do? Okay, I could return target. What I'm going to do instead is this, just because I could have just returned target without doing any of that work at all, right? So this is a little bit, and I hope this isn't confusing, but it's contrived a little bit, right? Because in our main function, all we're doing is we're saying, please find, for example, the number 7, and then it's going to output, I found it, and the data was 7, right? So I could just do that with a single statement in my find function, but I know I'm not, and those statements in my main function I know are actually testing my find function to see whether it's working or not, even though it looks like kind of dumb stuff actually in my main function. Question?
Yeah. What happens if it's not there?
Oh, good question. What happens if it's not there? Go ahead. Okay. So first of all, before I go there, I just want to make sure everyone's with us so far, right? Assuming that the target is actually in the list, this works, I think. Okay. What is what's going to happen if the target's not in the list? It's going to keep going, and then it's not going to keep going forever. It's not an infinite loop. Good. It only stops when data does equal target, right? But if we've got our entire linked list up there, and it goes down the linked list, and it gets to the end, what's going to happen? It's going to throw an error. I think we should just do that, okay? So you see. And then after I show you this, we're going to take a break. Didn't declare found. Oh, thank you. Maybe during the break I can go get some coffee. Okay, so I'm going to make up a list here. And then number to find. Let's find the 9. I found it, okay? Now, when I'm testing stuff like this, probably when I want to try to test, I'm looking for, so right there I just tested the general case, right? The general case being I'm looking for a number somewhere in the middle of the list. Okay? What would some boundary cases be? The first and last. Okay, so let me try 6. Okay, that worked. Let me try 5. Okay, that worked. And then there's one other boundary case we need to check. If the number's not there, right? So if the number's not there, like 12,
It doesn't like it.
Doesn't like it. Yeah, that's a good way. I like that way.
You mentioned maybe putting in a character in there.
Well, if the character in there would crash it even earlier. Okay, so right, a character, yeah, a character in there is going to Okay, now you've got me going. I need to try that. T. Okay, so what happened was it read my T, and it somehow stored it, even though it was wrong. Actually, no. What's going to happen when you try to read an integer, something that's not an integer, is the cin stream goes into an error state, okay, and the value of num just stays whatever it was before. Okay, so when I say while num is greater than or equals 0, apparently it was. So I tried to insert it, and it probably inserted something, right? Because it was something before. Whatever the garbage it was, I tried to insert it. It did insert it. And then it prints inner number to insert. And then this basically gets ignored because cin is in a error state. And apparently, and I'm not sure exactly what's going on there.
Yeah, I was thinking one like get the line just you know, legitimate numbers, but then when you ask to find something, you put it in there.
Well, that's what I did, right? Oh, oh, you're right. Okay, I did. Yeah, I see what you're saying. Question?
I thought when you put a character in the integer spot, let's try the hardest to convert it. So like A would be 0. So the question is, I thought that C++ automatically tried to convert the character to an int when you put a character where there was supposed to be an int. Yeah.
In your source code, that's correct. So when someone enters a value, what we're basically talking about here is how the extraction operator works, right? How does the extraction operator work if the right-hand operand is an int variable that the user enters a character that's not a digit? And what happens in that case is num remains unchanged, and the extraction operator, and the stream, cin in this case, goes into an error state. But I'm not sure why that made it so that it went into the loop once and then stopped after that. And sorry?
It didn't go to your friend.
Yeah. Anyway, that's probably not one of those things that we want to spend a whole lot of class time trying to figure out. So why don't we take a 10-minute break, and then we'll keep going when you get back. Okay, maybe I'll make this a little smaller. All right, so we, let's see, we're working on find. And so far we got it to work. The only case we haven't checked is the case where there is nothing, the target is not in the list. We checked it. We did check it, yes. We haven't solved the problem, I guess is what I should say. Okay, so any suggestions? If someone had made a suggestion that we say, And oops. While curve pointer arrow data is not equal to target and curve pointer, is that what you said? Okay. What? Huh? That's bizarre, right? How about if we say this? Curve pointer not equal to null. Does that make more sense? Okay. As it turns out, those are two different ways of saying the same thing in C++, because null is just represented by 0. And so if you want to be really clever and save yourself 5 characters of typing, you can just say and curve pointer. However, I don't think that's the easiest. I don't think that's the best way to say it. I think it's better to say it like this. Because really, yeah, I think there's a style convention that says something about treating bools, using the fact that bool is represented by 1 and 0 is not something you want to do. Yeah, that's my contention is that that's more readable. However, you certainly should expect to see the other thing used quite a bit if you're out there looking at code that other people have written. So, okay, is this going to solve our problem? So what you're saying now is that at least we won't crash inside the while loop. We'll crash after. Well, maybe we might have a problem here. Is that what you're saying? The while loop's okay now? Yes.
If one data was found,
Right. Oh yeah, I didn't set the value of found at all. That's a good point. So yeah, what I should have had before was this, right? Because I was assuming that the code that I had written was assuming that that it was there somewhere. So I got to figure out. Yeah, let's go ahead and finish this up. So now what do I know is true for sure after I exit my while loop now? It's more, I know it's not necessarily the case that curve pointer arrow data equals target, right? Either curve pointer arrow data equals target or curve pointer is null, right? One of those two things has to be true in order for the while loop to end. Okay? The reasoning I'm just a little digression here, okay? The reason that the reasoning that I'm using here works has to do with one of the style conventions that a lot of students hate, and that is that I don't want you to use break to get out of a while loop. Okay? And this is basically the reason for it, right? I want to be able to reason about my program by looking at the while loop condition. So looking at the while loop condition, all I have to look at is the condition on the while loop, and I can make an assertion about what's going to be true when I exit the while loop. Anyway, end of digression. Okay, so what do I need to do here? I'm going to have an if, right? Because I have to figure out whether it was found or not. So if, what do you suppose? If curve pointer is not null, okay, that means that I found it, right? That logic makes sense to everyone? If curve pointer is not null, that means that curve pointer arrow data must equal the target. So I can say these two lines. Oh, all I actually had to do was just. Sorry, the copy hasn't kicked in yet. Okay, but then we've got an else, right? If curve pointer is null, what do we want to do? found gets false. That's it. Because the way that we are defining this function is that the result is undefined if found is false, right? We could just put a return in here and return something just sort of random, some arbitrary value, just so something's getting returned. It's probably good practice to have your function return some. If it's a value returning function, it should return something. Okay, what do you guys think? Want to stare at that and reason about it a little bit and see if you think it's going to work? By the way, this is something that I think is actually good practice for you to do when you're writing your own code, but it's not what very many people do, right? Most people give it their best shot and then run it and see what happens. Yeah?
Why did you decide to make this a print function instead of a dual function?
Instead of bool, why am I returning
Because you
the...
know, yeah, because you know if it was found, it's the right number and it's there.
Okay, so I think what you're asking is why do I even have to return what I found?
Yeah, because you're returning 0, which is an arbitrary number, which feels arbitrary.
Mm-hmm. It is an arbitrary number, yeah.
And so you're kind of returning garbage when all you really care about is whether it's found or not.
In this case, right.
And so if we found the number, then we know it's there, and if we return true, then you can make assumptions that that number, you know what that
Right.
number was.
So the deal here is that we don't just care about whether or not it was found. We care what the value was that was found. And I realize my example is a little bit contrived in that sense because the value is just a 7. But so you have to imagine here that the data is more complicated than this. Maybe the data is a big record with a bunch of different fields in it, and you want to find the field that has a user ID of something, and what you're going to return is the rest of the data. So, and then this is just kind of like a super simplified version of that. Okay, I hope that. I mean, sometimes when I try to make things simpler, and it actually turns out making things more confusing. But I hope that makes sense. So, the main thing that we care about here is what is being stored in that node that we find. And it just so happens in this particular case that it's not very useful information because what's stored there is just the same thing as what we were looking for. If you were okay before that conversation and now you feel really confused, just kind of rewind, right? Okay, any other reasoning about this that you want to do? Is this going to do what we intend for it to do? Yes. Good question. Should we have a cout statement in here saying whether we found it or not? The answer to that is no, because this function is going to be a function that we're providing to a client programmer. And the client programmer may not want a cout statement to come out right in the middle of their attempt to find something in the list, right? So if any cout statements are going to happen, we want to leave that to the client program. Okay. So let me ask this. Let's trace through this. I'm resisting the urge to actually execute this yet. I want to reason about it a little bit longer, okay? Let's trace through this and see what's going to happen if the number we're looking for is not found. Okay? So we're going to get into the while loop. And we're going to go through it a couple times because the loop condition is going to be true. And then what's going to happen once curPointer moves off the last item in the list? So now curPointer is null. And so it goes back up to the top condition of the while loop. And the first thing it says is, tell me what curPointer arrow data is. What's going to happen when I say, tell me what curPointer arrow data is if curPointer is null? Not sure, but it's not good probably, right? So we try it. So, oops. 7, 2, 7. Okay, and so we're going to try to find 17. Oh, our little friend again. Okay? So what did we try to do that we are not supposed to do? Well, no, actually it's okay to try to find a number that's not in the list. Our function should do something that makes sense when the number we're looking for isn't in the list. Yeah?
Try to dereference null.
Exactly. I tried to dereference a null pointer. C++ is not going to like that. Okay? So let's see. What are we going to do here? Any suggestions about how we can fix that? Yes. So swap, use the commutative property of and so switch the operands around the and operator there. Does that make a difference? So I think what you're saying is, did I get that right? Well, I want to keep going as long as it's both the case that curPointer is not equal to null, and it's also the case that I haven't found it. And actually, think about it this way. If I said or, that would be an infinite loop. It would always be true.
Well, eventually...
It would eventually crash because I'm trying to...
find a null at the end of the...
Right, but when I found a null at the end of the thing, curPointer would no longer be not equal to null, but curPointer data, well, or, okay, so let's say it's or, and let's say that I find what I'm looking for. What's going to happen? curPointer is still not equal to null, so I'm going to keep going. Okay. This is a very a lot of students have a very hard time wrapping their minds around this question. A lot of students get the and or wrong when they're doing this kind of thing. So that's why I'm kind of spending a couple minutes on it here. I want to make sure that makes sense to everyone. I guess the way I would say it is, I want to keep going. As long as both of those are true. As long as curPointer is not null, and it's also the case that I haven't found what I want yet, I want to keep going. If either of those becomes false, I want to stop. Right? If curPointer gets null, so another way of saying it is, when do I want to stop? I want to stop if curPointer equals null or curPointer arrow data equals target. Right? And the opposite of that is what I have up there. All right, I'll let you ponder that a little bit. Okay. Now this is, you can actually ponder that after class too if you want. Okay. So back to the question, is this going to fix the problem? No one's brave enough to venture an answer to that question. Doesn't it perform both of the relationals first before it determines the end result? Yeah. Right. So this is called short circuit evaluation, which is how C++ evaluates logical expressions. It evaluates the first operand, and then if it already knows the answer at that point, it stops. That's short circuit evaluation. It's fairly important that you recognize that that is why this is going to work, right? If this was a programming language that did not use short circuit evaluation, this would still crash, right? So it's kind of nice that it does do the short circuit evaluation thing. There are programming languages that don't use short circuit evaluation, so you may find yourself in that situation someday. Well, I'm not sure. My guess is that probably modern programming languages all do it, but I couldn't swear to that. Anybody know? Like BASIC, if BASIC does Visual Basic? No one knows. My guess is it probably does. The one language I know that doesn't is Pascal. Anybody heard of Pascal? That was what I learned when I was in college, is Pascal. So we had to figure out some other way of fixing this problem. Okay, let's try this out and see if it works. Okay, so I can just make sure everything's still working. Find the first number, find the number in the middle, find the last number, and find something that's not there. Not found. Okay? Everyone happy with our find function? Questions about it? Okay, ready to move on to the next function? The next thing that I want to do is I want to be able to delete an item from the list. Okay, so let me type some more code into my client program. I can probably, it's going to be an awful lot like this, right? Int number 2, delete. Okay, so what I want to do inside is list.delete. Found, see out, the list is now list.print. Else, see out is not in the list. Num is not in the list. Enter number 2. Okay? Any questions about what I'm trying to do there? Okay, great. I have 10 minutes left in class and I'm finally starting to wake up. Okay, so let's go back and put a prototype in here. So oops. Okay, how do you suppose we're going to work this one? Similar to find. Okay, so I need a pointer, let's call it cur pointer. And I'm going to start it off at list, so that's exactly like the first line of find, right? And then a while loop, still looking awfully similar here, right? Should it be exactly the same as this? Yeah, I think it's going to be exactly the same thing there. Now, hopefully some of you are thinking, ooh, repeated code, repeated code. Bear with me for a minute on this one. While, oh, lost it. Cur pointer not equal to null, and list arrow data equals none. Cur pointer, this cur pointer, arrow, next. Okay, now either cur pointer is null or cur pointer arrow data is the node is what we want to delete, right? So if statement similar to what we have down below there. If cur pointer is not equal to null, that means we found it. Okay, and now I need to talk about how we are going to delete it. Okay, so let's get a picture going here. Here's my picture. And let's say that I was deleting the number 19. So that means I have a pointer variable here named cur pointer, and it's pointing to this node. Okay, so let's just go right to here. What am I going to have to say here to actually delete that node? So I'm going to have to get, excellent, okay, so I'm going to just looking at the picture, not thinking about code yet, I'm going to have to point this node over here to the third node. Okay, can I do that? No, I have a little problem here, right? I can't get back to that node. Any suggestions about how to deal with that?
Could you check the data property of the net in your router? Does that make sense? So do cur pointer or arrow net, arrow data or something?
Yes, that would be one way to do it. It gets a little dicey because what if your list has one item in it? Then the first thing you start out doing, so you have more special cases if you do that. And not to say that you would never want to do that, but it does involve some additional extra cases, but special cases you'd have to look into. Yeah.
Another practice
Okay, so that's a good way to do it. We're going to have 2 pointers going down the list. We're going to have a cur pointer and a prev pointer for previous. Oops, put in the wrong function. Okay, so we're going to start them off both as list. Okay. And then we want to say while cur pointer is not equal to null, move prev pointer up to cur pointer. Someone want to pull that door shut for me, please? Prev cur pointer. Huh. Let me actually draw a picture of this so that I don't just spew out a bunch of code at you now. So let's say that we're in the middle of our loop, and I've got prev pointer pointing here to the node right before cur pointer. So this is prev pointer. Okay. Now what am I going to do? Let's say that I'm not looking for 19, so I haven't found what I'm looking for yet. So I need to move both of those pointers down 1, right? What's that going to look like? I wish I could get both of those on at the same time. Hold on. There we go. All right, yeah, so the first thing I want to say is make prev pointer point to what cur pointer is pointing at. So prev pointer gets cur pointer. Okay, so that says this. Oh yeah. You get the idea. And then how do we move cur pointer up? Same thing. Cur pointer gets cur pointer arrow next. That doesn't change. So that's going to put cur pointer up there. Okay? So with those 2 statements right there, we successfully moved prev pointer and cur pointer up. Okay? So now when we finish our loop, we know that either cur pointer is null, or is this supposed to be not equal to? Or list arrow data or cur pointer arrow data, right, is not equal. Is equal to our target, the thing we're trying to delete. Okay. So now we just need to rearrange the pointers here. So found gets true. What do I want to say? I want to make this pointer right here under the 19 point to this node over here with the 12 in it, right? So that would be prev pointer arrow next get cur pointer arrow next. Let's try that, and then we can see if we like that or not. Prev pointer arrow next. Okay, when I say prev pointer arrow next right now, what memory location in my picture is that referring to? Prev pointer arrow next is referring to this box right here under the 19, right? Which is a pointer. Prev pointer arrow next gets I want it to point to the same thing that cur pointer arrow next is pointing at. Cur pointer arrow next. Okay? What else needs to happen? Hold on. Else. Found. Yikes. Gets false. Okay? So basically we're done. There's just one more thing that needs to happen here. I need to delete the node, right? So I made a prep pointer arrow next point to cur pointer arrow next. So nope. That's this, right? But I still have this node sticking around right here with nothing pointing at it right now except cur pointer. So I'm going to say delete cur pointer. Okay? Change the name of the function. Oh, it's probably, oh yeah. Can't call it delete, right. Any other questions? Go ahead.
I understand how that array is done and then it doesn't actually erase it.
Right. It doesn't exactly erase it, it just skips it. That's exactly right. Okay, so when we talk about our list here, there's a bunch of other stuff in memory here, all around here, that doesn't matter. All that matters is these arrows that are pointing one to the next, to the next, to the next, and that's what we consider to be part of our list. Okay? All right. Better stop there because we're out of time. When we get back next time, we will actually execute this and see if it works or not. I'm pretty sure it will. See you next time.